Today we're going to learn about function notation. Function notation is where you replace our y in our equation and you plug it in terms of a variable. Now x is going to be in parentheses, and so right here instead of y equals mx plus b, we have f of x is how it's pronounced, equals mx plus b. You can use other letters to name the function too, such as g or h, and it's different ways to name the equation or the function that we are given. That's the only change. So here's a couple of examples to show you how this works when you're plugging in variables and whatnot. All right, so we're going to evaluate these functions by plugging in different numbers. So the first one, evaluate f of x equals negative 4x plus 7 equals 2, when x equals 2. So when x equals 2, we plug it in with just that. Now we plug it in two places now. Instead of f of x, because there's an x in this function, that's what it's named, we're now calling it f of 2. So what we're saying here is, hey, we're plugging in 2 for x, so I'm going to tell you what that means in terms of this function. So I'm plugging it in to solve it. Now, just an FYI, because we have f of 2, we are not multiplying it. You keep it as is. Think of it as just a title or a name. So when we go ahead and solve this, we do get f of 2, that means we plugged in 2 for x, equals negative 1. And that is our answer. So that's telling us, hey, in the function of f, when we plugged in 2 for x, we got a negative 1 as our output. Now let's try it for the next example. We are plugging in 3 different numbers. So I'm going to have an f of negative 4. I'm going to have an f of 0. And I'm going to have an f of 3. So we're really just plugging these numbers in for x, but we're naming it. We're going to say, hey, we are plugging in a negative 4 for x. This is what we get. So go ahead and mental math, find out what these answers are. So 2 times negative 4, okay, negative 8, minus 5, okay, so that's negative 13. So what this is saying to me is, hey, in the function that we have, when we plugged in negative 4 for x, we got negative 13 as our answer. F of 0 would be negative 5. And f of 3 would be 1. And that's just what your answer is. So go ahead and try the next one on your own and see how you do. All right, when I went ahead and found the answers and evaluated the function, I got when I plugged in negative 4 for x, I got 3. I plugged in 0 for x, I got negative 1. And for 3 for x, I got negative 4. Now these examples are a little different because they're not telling us what x is, they're actually telling us that the function completely is equaling. So we're kind of doing the opposite. So it says to find the value of x. So we don't know what x is, but it's when the function h of x equals negative 7. H of x, if it's equal to negative 7, you just plug it in right there. So instead of h of x, we're having negative 7 equals 2/3 x minus 5. So it's really like we plugged in negative 7 for y, but remember we replaced it with this function notation. So now I'm going to go ahead, I'm going to add 5 to both sides where I get negative 2 equals 2/3 x. Now, here's a little trick. If you think of 2/3 as separate entities, 3 is really dividing 2. So I'm going to multiply both sides by 3 so I don't have to use my calculator. And I'm getting negative 6 equals 2x. Because 2 is on the top of the fraction, the numerator. Now I'm going to divide by 2, and I get negative 3 equals x. So what this is saying is, hey, when the function is equal to negative 7, that's when we plugged in negative 3 for that variable. So go ahead and try the next two on your own and see how you do. Again, you're kind of plugging it into the y value, but we don't have y value anymore. We have this f of x and then g of x. That's all we're plugging it in for. Check back and see if your answers are correct. All right, so when I plugged in 21 for the f of x side, I found that when we had plugged in 2 for x, that's when you get that the function equals 21. And then when you plugged in 8 for x, that's what I got on this answer, that's when you get the function to equal to -1. Now we have to start graphing these linear functions in function notation. Guys, this is the same thing as slope-intercept form. All you have to do is find your m and your b. The only difference is instead of y equals 2x plus 5, we have f of x equals 2x plus 5. That is it. So I'm going to go up to 5 as my y-intercept, and my slope is 2, which means I go up 2 over 1. Or if I run out of space, I go down 2 over 1. And then I just draw my line. It is exactly like slope-intercept form. Go ahead and graph the next 3 on your own and see how you do. All right, these are the graphs that you should have by the time that you are done with graphing these in function notation. Again, just like slope-intercept form. Now we're going to graph this function of g of x, but we also have to compare it to the graph of f of x equals x. Okay, so we're going to graph both of them. And the first thing I'm going to do is I'm going to graph this f of x equals x. Now what that is the most basic linear graph that we can get. It is a graph of a slope of 1 and the y-intercept is at 0. So it's just a complete diagonal line that cuts through the graph exactly. Now I'm going to graph g of x, and I'm going to do this in blue. So when I go down and then I go ahead and graph this function, you see that it's a little different. So when I compare it, we have to just say certain things about the graphs. So first off, I'm going to say they have the same slope, which is 1, but the g of x function translates, which also means or slides, right, down 3 units. Okay, so what this is saying is, hey, these are pretty similar graphs. However, all that happened with g of x that is different than the f of x function is that it translates, or it slid down 3 units. And that's it. Go ahead and graph negative 2x as well as g of x function of negative 2x plus 3. Graph them and then compare them to each other. Check back and see how your answer is. All right, so this is the answer you guys should have gotten. When you graph them, you should again see, hey, they have the same slope, but the function of g of x translated 3 units up from the function of f of x. Go ahead and try the very last one to see how you do, and you might not even have to graph it to find out what the comparison is between these two functions. All right, so you should have said that the function of h of x and f of x, they do have the same slope, they are parallel, but h of x translated down 5 units because its y-intercept of negative 5 is 5 lower than the 0 intercept of f of x.